We will be. So we got Kevin as an intern on the Big Chance project. Um, he was open to work on many different things, but we decided that we would like to try to do some machine learning, and we weren't sure exactly what to work on, and so we did some discussion, Roy, Mike, and me, and thought it might be a good idea to understand if there's a stress or no stress in the recording. So Kevin will explain a bit more about the use that we might find with this. And yeah, so it's been 2 months. Yeah, 2.5 months. He's
Tomorrow's
finishing. Tomorrow's the last day, so he'll be leaving us soon. We will be streaming his when he does his defense. I'll announce it. We can all watch it here. They will be streaming it. We will stream his live, and we can ask him really difficult questions to make him stutter.
That's
Thank you.
September, right?
Yeah.
Yeah, the 5th of September.
Remember. So, anything else you want to say, Roy, about this?
No.
Okay, just give me a second. I just want to fix the size because we're recording this. Okay, d'accord. Ça va marcher maintenant.
Okay, so as Sarah said, I'm currently studying in Switzerland in an engineering school, and during the final year we have to work on a project full time for like 2 months and a half approximately. And some students have the opportunity to go abroad. So I am a lucky student, and I had the opportunity to come here to do this, which is an awesome experience. So this is my bachelor thesis. I will graduate as an engineer after this, after having defended my project and that stuff in front of experts.
Unless we ask you a lot of difficult questions.
Yeah.
And then...
And yeah, so my project is called Stress Detection Through Speech Analysis. So as I told you, this is my bachelor thesis. The main goal is to detect stress occurrences during an interview, record interview from a candidate that will send you some videos after having answering questions on Big Chance. So it could be a nice improvement, a new feature for Big Chance, because for example, it could help candidates to prepare for the interview. Like he can practice, then he can see when he was stressed, and maybe some indicators could tell him, okay, he was stressed here, so please calm down, or that stuff. But it could also help recruiters to make their decision, because if a candidate was really bad and really stressed, maybe you can say, okay, it was not that good, but he was really stressed, so you don't really know. So the use is, you can do whatever you want with this, it's just the concept. So maybe I do a little demonstration of something that I've done. Where is it? This. So this is my little module. I choose a classifier. I will explain later what it is. An interview file. This is an interview from Junji. It was just a tryout. So if I start the experiment, it runs for a while. There is no user feedback, I know. Then finally you have this who pops out, and you can see on the y-axis the stress percentage, which is really low. So Junji was not stressed at all. And here the duration, so you can see how stress varies through time. So this is basically the output you can have.
Do we have a video with some stress person?
No, unfortunately not.
Actually, what we were suggesting is trying to look for something on YouTube to find something like some scene where someone is really stressed and see if it would work. I haven't done that yet though.
Yeah. So now we'll go through some steps to explain to you how I achieved this. So the first one is to find some audio features that could help me to classify if the audio signal was stressed or not. Then finding some data sets. I will explain what it is and how it works. I built some feature sets then. I will also explain to you what it is. Then I train some classifiers. So for the features, there are many features that can be extracted from an audio signal, like pitch, which is the frequency of the vocal cords, the mean intensity, the mean energy, speech rate, all that stuff. So I made a lot of research about what features could be interesting for me. So after that, I found out that with the mean intensity and the mean energy, I might be able to dispatch emotions, to recognize 5 of them. Then I also see that the male frequency substrate coefficients are widely used into speech recognition problems. So I will explain you what it is later. So all this feature research leads to feature set building, which will be used for the classifiers at the end. So, for example, what is a feature set? So let's say that we want to classify cars or trucks easily. So, for that we have some features like the weight, the length, number of wheel, or the tire width, something. It's just an example. So with these values, we can say that, okay, this is a car, okay, this is a truck. So this is basically how a classifier feature set is. So on the left you have the class, also called the label. So it can be whatever, but it's just some classes. Then on the right you have the features that helps to classify this sample. So it is a car, a truck, or whatever. So now the MFCCs, to be shorter. So the concept is kind of difficult because there is a big problem with the interpretation of these values, but I will explain you what it is. So these coefficients represent the shape of the sound produced by human beings. So when you talk, your vocal cords, the teeth, and the mouth, everything, the sound is filtered by all these organs. And all this data is can be found in the sound through the MFCCs. So it's based on the Mel scale, which is a scale really close to what the human ear can perceive. So this is why it's really used into speech recognition problems. So there are several steps in order to extract these coefficients. And an important one is that the signal is framed into several parts for 20 milliseconds, and 13 coefficients are extracted. This is important because it leads me through some problems and some stuff, so I will explain you later. So if we visualize these coefficients, it does not really help us because on the vertical axis you have the coefficient number, and the horizontal axis the time, and you can see that the more red is the color, the higher is the value. But the value, we don't really know what it means, so it just value from like -50 to 50 or whatever, but we don't know what it is. So this is the big problem with these MFCCs. There is a big lack of interpretation, and nobody knows how to interpret these numbers. And I mean, there is no way to interpret them. So for a human, this is impossible to, by seeing plots like this, to see, okay, this is this emotion, this is that. So that's why computers now are really, really useful, because all these numbers, we can do something with that. So the data sets, I was able to find 3 data sets, one in German, one in Japanese, and one in English. The German and English one are sentences spoken by actors. These sentences are spoken with different emotions. So we have a ground truth, so we know that this sentence is, for example, anger, this sentence is stress.
Isn't everything said in German angry?
No.
Not stressed. Angry, but not.
Schmetterling!
And the Japanese one is a little bit different because it's only words. and there is 47 different emotions, so a lot of emotions that are useless for the project, but still, it was interesting to see the differences. So now, because of these MFCCs, because as I told you, a signal is framed into 20 milliseconds, and certain coefficients are extracted. So if I have a 2-second file, I have more than 10,000 coefficients. So it's really, really big. And I didn't know how to handle this, so I tried several ways, as you can see. So first, I built a set without the MFCCs to see if my assumptions were right, that with the mean energy and mean intensity, I might be able to differentiate the emotions. The second one contains the MFCCs, but each value is used as a feature. So it means that I have more than 2,000 features. The third one is only with the MFCCs, because I wanted to see if the mean energy and mean intensity could help into recognition, with the recognition. And the last one, I tried to compute the average and standard deviation of each coefficient. So it gives me 28 features at the end. So now the classifiers. So basically, the classifier's job is to take some data in input, some features, value, and say, okay, with these values, I've got this class. So in order to be able to do that, the classifier, CLF, needs to be trained with some data, with some label data. Data that we know that, for example, like I told you before with the data sets, I take an audio file, I extract the features, and I know that this audio file is stressed. So I can build a feature set and give it to the classifier. And behind the classifier, there is an algorithm that do all the stuff to learn. So I won't go further in the details with that. So once it's trained, I can give him unlabeled data, so only features, and he's able to say, okay, this is this class, this class. So this is basically how it works. So, and even if the main emotion was stress for the project, since I have datasets with a lot of emotions, I selected 5 of them, which are anger, sadness, happiness, stress, and disgust. These are the 5 I've chosen.
Aren't these similar to the ones we're using in Vibe? Anyone here in Vibe?
Positive versus forward.
Yeah, exactly. Yeah. So yeah, what I've done for my tests is like I trained classifiers with every feature set format, so it gives me a lot of results, and I use super vector machine and neural networks for the one who knows what it is, as algorithms for the classifiers. Then I tried to determine which feature set construction was the best and gave me the best results. So in the end, I had these results. So accuracy score is the percentage of good results among all the results retrieved. So for a multi-class feature set, which has the 5 emotions I told you, I have some accuracy scores around 80%, even 87 for the German one, which is really good. And when I have a 2-class feature set with only stress and no stress, I have 95% scores, a little bit less for the English one. This can be explained because the sentences are a bit longer, and also this is the biggest one with more than 1,000 samples. So yeah, the results are really, really good. I did not expect such good results.
So if there's more samples, the results are worse?
But maybe because you can learn from more data. But I don't know. It should be the opposite, better results.
Maybe the file is long.
So another interesting thing is that with the German dataset, which is the QSD, I have 95%, but the sentences, the words, are only like a half a second long. And for the German one, this is sentences for like 2 seconds, and I have also really good results. So what we can say...
I have a question. How do you measure these results? Is it a 50-50 splitting the samples?
Yeah, exactly. How I compute this score is I take the feature set and I split it in two parts: the training set and the test set. And I use the train set to train the classifier, then the test set to make him predict these levels. Then I compare the results between the one predicted and the real ones, and it gives me these results.
And these are, you train on the same set. You didn't try to train on the German one and then test it on the English one?
I haven't tried yet. I will do it for my delivery, my report, but I haven't tried yet.
Okay.
Does it matter whether the voice is like male or female or older or younger?
This is an excellent question. The problem is with the German and the Japanese one, I have only male speakers. But with the English one, I have females and males. But I haven't tried to split that in. I haven't taken this in consideration.
What is your assumption about that? Would they be different? You think? Or?
Maybe, yeah. Because maybe women tends to have higher. I know that they have higher frequencies. I've read that. But I think it will be a bit different. But I cannot be. I'm not sure.
Maybe that's why the accuracy was lower. It's because it had both of them. Makes kind of sense.
Maybe it makes sense.
Are they randomly split?
Yeah, but I did some cross-validation. So cross-validation is finding the optimal test set for the training set. So what I do is I split the set, but every time in a different way, in order to find the best way to do it. So maybe to conclude, we can see that the features widely affect the result because without the MFCCs, I had really bad results, but with them, really good. So this is feature extraction is a really important step in machine learning. So this project shows it. The neural networks are slightly better. So slightly because only maybe 5-10% better accuracy scores. So the last feature set I built with the average and standard deviation of the MFCC is the best. So this was a really good approach, I think. And the results are really satisfying because I've only worked on the project for like 2 months. And I think for this amount of time, the results are really good. Some improvements can be made, but still the accuracy scores are really good. So maybe on a different note, I would like to thank you, all of you, for having given me the opportunity to come here to work for you. And I hope that my work was satisfying. So thank you, everybody. And now if you have questions, I'll try to answer them.
Mike?
What would be your next steps to improve those results?
Add more features. I had some constraints to use only the Python programming language, but I think with some other softwares and maybe other libraries, I could get more features and build a bigger feature set.
What kind of features?
The pitch, for example, the vibration vocal forms. But I suspect that this can be retrieved through the MFCC because it's part of the shape of the mouth and that stuff. So I will need to try. Also do, like Roy said, to split into female, male, to do something more, to focus more on something. For example, if you know that the person being interviewed is a woman, use a women classifier, or really like focus on the person that is going to be interviewed. Also do some algorithm tuning, because here I use 2 algorithms, but prior to this project I didn't know these, so I had to learn them during like 1 week or 2. So if you spend more time on the algorithms, you can probably have better results. Because there are like 20 parameters for neural networks. I only used 5 or 10. And I don't even know validate. I don't even know clearly how it affects the results because it's kind of complicated, and in 2 weeks I cannot learn everything.
What about if there's noise?
This is also something that have to be tried, because if you have noise in the background, probably the results are going to be worse. But the MFCCs discard in a way some noise.
Oh.
I don't know how it does.
Okay.
Just the sound you have, it's only like studio sound, right?
Yeah.
Mm. It's recorded, yeah.
So I should change.
I mean, we're, at least for us, we're,
No, yeah.
we're assuming that someone, like people will not take an interview in a crowded room.
No, of course.
Yeah.
So,
If you want to use it somewhere else.
yeah, definitely. Yeah. But that could be a future improvement.
Like in CSI.
Like CSI. Any other questions?
So in the dataset, how they measure the stress level or something? Because
No. You mean when I got the data sets?
yeah, so the organization prep their own data and
Yeah.
future with stress or not stress.
Yeah, I mean, stress is hard to define as an emotion because everybody reacts differently, but it's really close to anxiety, especially when it comes to interviews. So that's why I use anxiety as a main emotion.
How they measure the anxiety from voice?
Yeah, so these are actors that spoke some sentences though, so it's not really measured.
You just said
This is a good
this
question.
sound
It's labeled.
is when you stressed out sound.
Yeah.
Is that only stress or not?
No.
Or there is some level 0.1.
No. So the files are divided into, this is an angry way of saying hello, this is a happy way of saying hello, this is a sad way of saying hello. So they say the same word, some of the sets will say the same word in different emotions.
You don't have the stress levels.
Hello. 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 So stuff like that. And that's how it's labeled already.
Can work like that.
So
I mean, yeah, that's how you can learn from it. Yeah.
So, and also, even in Japanese, Japan, so people in different region has totally different accent. Some people conversation sounds very angry. 2 minutes. For instance, so
Yeah.
how did you deal with different regions conversation?
to do that, you have to have data sets and train your classifier with that because you cannot really do anything about it. So because everything relies on the data you got at the beginning. So if I don't have this kind of different accent or stuff, I think you cannot really do.
And that's why I was asking that it would be very interesting to do the training on the English set and see what the results are on the Japanese set.
Yeah.
Maybe they'll be very bad. I don't know. Yeah, we have to definitely try that.
This is something I will do until the end of the project.
Or Chinese conversations are anyway.
Yeah. Some Arabs are always screaming at each other.
Yes.
So now you focus on stress. Is there a way to focus on honesty? Or
I don't
I've done some research using sound for.
I don't think I have data labeled as honesty.
No, like what emotions? Do you know what emotions you would look for if you're looking for that?
What could be close to
Yeah.
Did you make evaluation under real situation like the Junji's voice?
no, you mean what? Sorry.
Situation.
And the real situation.
No.
For example, the Junji's voice or my voice.
No, I haven't. No, I just use the data that I've got from the data sets. I haven't had enough time to try more experimentation.
Well, you saw Junji's voice. It had zero stress. So I don't know. But it's. I mean, obviously, in this case, he practiced it like 4 or 5 times, so there was no stress there. So it would be useful, like what Mike said, to actually find a video with stress and see if it would catch it or not.
But since you are doing right now some interviews for a future employee, maybe it would be interesting to just put the video in the program and see what it outputs.
Yeah.
How long is it taking to have the result for a video of like 2 seconds?
As you saw, about like, I don't know, 5 seconds.
No, but this
The
was
predicting is really fast, but what I've done is I split the video into really, really small frames. So the more frames you have, the longer it takes, obviously.
I want to improve it.
I don't think you can improve the way how fast the emotion will be predicted, except by doing some algorithm tuning.
Or you teach the video, or you work on the audio.
oh, we do.
That's what I do.
But it's a dot smoke. So
No, but I
Yeah,
mean,
but I extract
Even
the
when the-
audio
it's
into
in the
wave
frames?
format.
Video is already long gone.
yeah. But I mean, you could improve the. I guess I would assume you can improve the performance by doing some parallel computing. But I mean,
Ah, yeah.
For honesty, you would probably have to check gaze.
the video itself, the images.
Yeah, the gaze detection.
Uh,
And also, I know that some algorithms were able to detect your pulse from your face because there's minimal color change in your face.
wow.
So, if you could track the pulse through that, well, we're going closer to light detection.
I think if you combine this and
Lie
face
to me.
detection, you could do really,
lie to
really
me.
good.
Go for surveillance.
You lie for an interview.
Please lie.
Anything else? We good?
Small question. In your journey of your research and so on, have you ever did you found any tools or ways that you can use to transcribe the voice to text
No,
conversion?
I haven't.
You haven't explored this past.
I haven't been into that, so
Hmm.
every time I saw something, I was like, "Ah, no, I'm not interested."
I have a question, maybe it's for Fred actually. Can we put a patent on this?
No, I think there's a lot. I mean, we're using algorithms from libraries that. I mean, we didn't create any of this.
That's not a problem.
Really?
You could use any tool as long as what I'm doing is new.
But the thing is, we have to get our own data set and train.
I mean, you can buy if you pay somebody to buy
What for?
Usually the
I
tool is
was just detecting
based on the
Yeah.
data.
audio.
So if you use data,
If we were actually use it and implement it into a product, I would consider patenting it too. Until we reach
So
that
that's why they
stage.
check everything.
Yeah, but if we're we pass this stage of we know that we're gonna use it, then if we don't reach that stage, then patenting is a lot of money and time. So it's a trade-off.
All right. Thank you. Thank you, everyone.
Thanks a
you.
lot.
Stop the
We
stream.
need enough for the next selection.